Now let's continue with integer types. Previously we looked at assigned and an unsigned int. Now I will introduce you to two new modifiers, short and long. So let's look at the short and an unsigned short first. Short can hold both positive and negative integers. Its size is 2 bytes or 16 bits. So the numbers range from minus 2 to the power of 15 to 2 to the power of 15 minus 1. An unsigned short holds only positive integers, so its range is from 0 to 2 to the power of 16 minus 1. We already looked at an int and an unsigned int, so let's skip it. Now a long and an unsigned long can also hold 4 bytes or 32 bits, so its range is similar to an int or an unsigned int. However, a long can hold up to 8 bytes or 64 bits, so its range is from minus 2 to the power of 63 to 2 to the power of 63 minus 1, while an unsigned long holding only positive integers ranges from 0 to 2 to the power of 64 minus 1. Next, we will see integer overflows. We will look at integer overflows through example. So the code snippet that I'm showing you here is declaring a variable called value. Its type is an unsigned int, and we are storing the maximum value an unsigned int can hold. So 2 to the power of 32 minus 1 is the maximum number an unsigned int can hold. We are storing that within value. And in the next line, we are incrementing value by 1. That is, we are adding 1 to value and storing the result back in the variable value. Now what happens when we do this addition is, we know that an unsigned int has 32 bits, and the maximum value is when all the 32 bits is equal to 1. Now if we add 1 to that number, all the least significant 32 bits will be 0, and the 33rd bit will be equal to 1. However, the result can only hold 32 bits. So it only holds the least significant 32 bits, which are all zeros, and the 33rd bit will be lost. So an overflow occurs and the value goes from maximum to minimum. That is, it's going from 2 to the power of 32 minus 1 to 0. So we will switch to Visual Studio, execute the same piece of code, and we will verify what is the value after this computation. So let's look at Visual Studio now. So the code again is the same as before. Now before I execute this code, I want to show you something in Visual Studio. So look at the way I've organized the solution file here. My solution file has multiple projects. To add a project to a solution file, you can right click a solution file, go to add. You can either select a new project or you can add an existing project. So what's nice about this is that you can organize all your projects within the same solution file, and you can switch between different projects by right clicking on a project and then clicking set as startup project. What this does is it will select this particular project to compile and execute. So you can store multiple projects. Each project can have its own CPP file and a main function, and you can switch between projects within the solution file. So now I've selected integer-2. I'm clicking set as startup project. So this file will be compiled and executed. So let's execute this program. Now notice after adding 1 to the value, the result is equal to 0. So this is what we expected. Since an unsigned int can hold only 32 bits, an overflow occurred and the result only shows the least significant 32 bits. Now we'll see the opposite scenario wherein we will initialize value with 0 and subtract 1 from it. And then we will see what happens once we subtract. We know 0 minus 1 is equal to minus 1. However, an unsigned int can hold only positive integers. So the result should again overflow, and now it overflows in the opposite direction. We should see the maximum value stored within this variable value, which is equal to 2 to the power of 32 minus 1. Okay, so now notice after subtracting 1 from 0, we see the value will be equal to 2 to the power of 32 minus 1, which means an overflow again occurred. So this shows that an overflow can occur either during addition or during subtraction. So we need to pay attention to what is the type of the value and what kind of operation can be performed based on the current content of the value. So it's always good to check whether it's holding the maximum number when we are adding for an unsigned int, and we should check whether the number is greater than 0 before subtracting 1 from it, when again the type is an unsigned int, or we should change the type from an unsigned int to a signed int before doing the subtraction. Next, let's look at a more realistic example. This was a more contrived example. In the next example, we will look at a case where a game which was released in 2008 had an overflow issue. So a variable called boss underscore health was declared in this game. Its type was short, and its initialized value which is equal to 32,000. So we know the maximum value a short can hold is 32,767. So a short seems to be a reasonably good choice for storing this variable boss underscore health. However, this caused an overflow, which was not intentional. So let's look at how this happened. So first I'm printing out the value of this variable boss underscore health, and then I'm incrementing it by 400. So what this does is this is adding 400 to the variable boss underscore health, and then it's storing the result back in the same variable. So let's see what happens when we continue the program. Notice 32,000 is the initial value of boss underscore health. After adding 400 to it, its value is 32,400. So far good. Now in the next line, we are again adding 400 and saving the result back in the variable boss underscore health. So its current content is 32,400. Now if we add 400 more to it, it will be equal to 32,800. However, the maximum value a short can hold is 32,767. Therefore, this should cause an overflow. So let's see what happens. Okay. And now notice the value after doing the addition is a negative number. So how this impacted the program was, a player could apply a few powerful magic against the boss. Instead of damaging the boss, this powerful magic healed the boss. So instead of decrementing the health was incremented. And within a couple of moves, boss health overflowed from a positive to a negative number, and it was defeated. So you can watch this video in YouTube where you can actually see what happened in the game when this occurred. It's quite funny. So go ahead and look at this video. For now, what I want you to remember is it's important to make sure that we will never use the tightest type that fits our value. We should always use a bigger data type and foresee that there could be overflow issues. Here, the program did not anticipate that the health will be incremented instead of decrementing, and they use the data type that holds, that can hold the tightest data type that can hold the value. So imagine if the type was an int instead of a short, it would have taken more than a couple of tries for a player to use a powerful magic and make the boss overflow. Now let's switch to a different scenario. Here I'm again declaring a short. Its name is n. It's initialized with value equal to minus 32,768, which is the minimum value a short can hold. And then I'm dividing it by minus 2. So let's see what happens when I divide it by minus 2 and store the result back in n. We know that when we divide a negative number by a negative number, the result should be positive. And the result is as expected. It is 16,384. Now let's see what happens in the next line. In the next line, I'm dividing the same, initializing n with minus 32,768, which is the minimum value that a short can hold. And I'm dividing now it by minus 1. So after the division, the result should be 32,768, which is greater than what a signed short can hold. So the result should overflow. So let's see what happens. Again, notice result is now a negative number. So we divided a negative number by minus 1. So the result should have been positive. However, the result is negative, which means an overflow occurred. So what this says is that an overflow can also occur during division. We already saw that an overflow can occur during addition and subtraction. So we need to be careful as to what we are dividing when we are using what data type we are using and what operation we are performing.